All right, so we're doing an LOL diagram. You finished your pyramid, and you've got all of your food chains in here, right? So the green check marks represent the organisms from those 3-chain food chains. The red check marks represent the organisms from the 4-chain food chain, and the blue represents organisms from the 5-chain food chain, right? So with an LOL diagram we call it an LOL diagram because that's what it looks like, but it's really 2 graphs. It's going to be a bar graph. We say bar graph, we use it for categories. And so our categories in our bar graph are the organisms in the food chain we're showing. Does that make sense? The organisms in the food chains we're showing. And you're going to graph the amount of available energy in each organism as they're consumed, right? The O in the middle is the system. So we say ecosystem, right? And so if we're just talking about, when we're doing the LOL diagram here, we're talking about the living things. So this is all biotic, not abiotic. So we're saying what is in the system. So what I'm going to ask you to do is choose, it doesn't matter, you can choose one of the 4-chain food chains. And what you're going to do is you're going to list those in the system. So I'm going to find mine down here. And because it's easy, I'm going to do the aquatic one. So I'm going to go plankton, zooplankton, sand eel. Was it puffin? I think so. Puffin. Plankton, zooplankton, sand eel, puffin. So I would label that, and I'm just going to use initials here. Plankton, zooplankton, sand eel, puffin. And so on my graphs, I would have these categories written out. I would like you to write them, not abbreviate. And each graph is going to include the organism, even if it's already donated its energy to the next organism, even if it's, for lack of a better word, dead, right? So I'm labeling my graph with 4 categories. Each category is an organism in the food chain: plankton, zooplankton, sand eel, puffin, right? Okay, and at the start, then I'm going to list those organisms in the system. So I can write them out. Plankton, zooplankton, sand eel, and puffin. Okay? And all of these are in my ecosystem, right? Now, if I wanted to, I could have a previous graph and I could show that there was no energy in the system before the sun came out in the morning, right? And so then I could have a second graph that shows 100% energy in my producer, which is my plankton, because all that came from the sun. If I did that, then the sun would be something that is outside the system and gave energy to the ecosystem. But we're just talking about the system. So we're gonna make an arrow that says plankton, zooplankton. And that arrow is what these 2 graphs illustrates. So I'm going to make a bar for plankton, and up here I'm going to write 100%. Plankton has 100% of the energy, right? We said our producers have 100% of the energy in our ecosystem. And how much energy is passed on after an organism is consumed? 10%. Good job, Luis. So 10% is passed on. So after the zooplankton eats the plankton, now the energy is here, and there's only 10%. Right? So now I can color that a different color, which is what I'm going to do. Blue. 10%. Okay? So now I'm going to move on to the next stage of the food chain, and I'm going to illustrate how each time that bar graph is going to drastically get smaller and smaller, right? So I would write the same organisms here: plankton, zooplankton, sand eel, puffin. And I'm going to go ahead and write them down here too, because these are the organisms in my system. If you were to erase one of them, I would understand, because you might be saying, hey, actually, Coach Smith, that plankton was consumed. It's not in the system anymore. But we're talking about, if we're talking about populations, that's probably not true, right? So in this scenario, the zooplankton gets consumed by the sand eel. The energy goes to the sand eel. So the graph in the after becomes the graph in the before for this, and that's 10%. Okay, so if the zooplankton has 10% and it's eaten by the sand eel, how much percent of the original or energy does the sand eel have now? 1%. So it moves a decimal point. So we're going to illustrate that by sand eel, and I'm just going to make a bar that's just above that line. Okay, and I'm going to use black for it. I'm going to color it in black, and I'm going to say 1%. Then I would go to the next round, and so I would start out with only 1%. And so what percent is left over for the puffin when it eats the sand eel? 0.1, very little, right? And so this is just another way, and I'll just do this. I'm going to make a red line on the line, and we're going to call that 0.1%. And so what you have done is you create this LOL diagram. It's a different way to illustrate energy change. And we use it in science, not just in life science, but also when you do some things in high school. So this is a skill and a diagram I want you to become familiar with, but it's not necessarily something you have to master in 7th grade. So this is why it is a bonus opportunity. If you take the time to illustrate your LOL diagram, then I will take the time to grade it, and we'll use that to give you credit for your lowest assignment. That is not a test grade. So you can copy this from the key, and then on the back of that paper is where I'd like you to just draw LOLs, 3 of them, and you'll label it similar to this, right? You can watch this video for an explanation, and then there's kind of a diagram copy that's already on there. Okay, any questions about it? It's kind of simple, it's just a little bit different. All right. Thank you.